And welcome back. Today we're looking at 1.3. We're looking at angles. So kind of exciting. We're not looking at those lines and line segments anymore. So we're going to be looking at these angles which are formed when two rays have the same endpoint. Don't forget, anything that you see is blank on your page. You want to make sure you're writing down from the filled in notes. So what are rays again? Right, so two rays, one ray is something that has an endpoint but goes on forever in one direction. So for example, one ray that we have here is ray EW, right? Starts at E, goes through W, and on forever going up that way. Okay, we also have a ray down here, ET, starts at E, goes through T, and on forever to the right. Now, how do we name an angle? Well, there's something very, very important in an angle, and that is that turning point. So that point where the rays meet, right? That intersection point. This is what we call the vertex. The vertex is really crucial in how we name an angle. So an angle can be named by its vertex, so angle E. We can also use 3 letters to name the angle. So we can also call this angle TEW, meaning we start at T, go round to E, and then go up through W. But see how that vertex is in the center. All right. You might also notice in this diagram, there's this little 1 here. This 1 isn't talking about the size of the angle. This is just another way of naming the angle. So instead of calling it angle E, you can also call it angle 1. All right. So that's how we name an angle. Now, remember how segments, we had the idea of the segment, the figure of the segment, and then the measure of the segment when we put number of values to it, and the notation was different? Same deal here for angles. When we're talking about this angle E or this angle 1, we're talking about just the image of it. But if I want to add a measurement to it and say, well, this angle is 50 degrees or 20 degrees, we need to add a little m in front. So when we're talking about numbers, we want to add a measurement. We're going to use this notation. Put a little lowercase m in front of the angle symbol and then name the angle. So the measure of angle E is equal to, for example, 25 degrees, right? And that little circle means degrees, just like temperature. So just be careful when you want numbers, we need to use that little m. Okay, what kind of angles do we have? Well, angles are measured in degrees, like we said earlier. Make sure you fill that out, right? We use what we call a protractor to measure that. And we're not going to do any protractor measurements here with the video, so bring your protractor to class and we'll be talking about that and doing that measurement in class. But we have some special angles we can classify based on certain degrees. So the first we're going to talk about is what kind of angle we have when the degree is between 0 and 90. All right? So we're not at 0, but we can be anything like 0.0001 all the way up through like 89.99999. And x here is just the degree. Let's just make that clear. That can be any value, my variable. So that's going to be some kind of angle that looks like this, right? Like a kind of like a less than sign, almost like a corner, but not quite. These are, these angles between 0 and 90. And this is called, you might already know this, an acute angle. Okay. So what happens when we actually hit that 90 degrees? And oops, I forgot my degree symbol. Super important when we talk about numbers. We want to put labels if we can. So what happens if we have something that's exactly 90 degrees? Well, that's like when most walls hit the floor, right? It's going to look like an L. To make sure we indicate this is 90, we use little corner symbol, right? So that means 90 degrees. Right there, if you see that in diagram. You might know this. This is called a right angle. Okay. Then what happens if we get bigger than 90? Well, between 90, and again, x is just my variable. It represents any angle measure, right? So 90 is less than x is less than 180. So not quite 180, anywhere up to 179.9999999, right? So these are going to be pretty huge. They're going to look like really, really large angles, for example, like a really wide V. Some of you might draw seagulls like that in your pictures. I know I did when I was little. But this is what we call an obtuse angle. Okay? Then finally, our last special angle we want to know is what if we hit exactly 180? Right? Well, 180 is going to actually look like a line or a line segment. So we've got our vertex right here. Your two, sorry about that. Your two rays are actually going to be opposite rays. Kind of neat to notice that, right? These are opposite rays. So we have a straight line, so it's called a straight angle. So make sure you know that vocabulary. We're going to be using that when we talk about some angles. Okay? Taking a look at example 1, we're going to skip all this and we're going to talk about example 1, example 2, and that practice in class. And let's skip down to the angle addition postulate. Okay? So you want to make sure you're writing this down. If any point S is in the interior of any angle, for example, PQR, then the measure of angle PQR is equal to the measure of angle PQS plus the measure of angle SQR. Let me just delete my ugly highlighting there. Oops. Okay. So you want to make sure you're writing that down, and let's think about what this means. Do you remember when we talked about an addition postulate before? Right, that was your segment addition postulate, where the parts add up to the whole. So the same idea here. It can be any angle with a ray going through the interior of the angle, right? So this QS cuts through angle PQR. And that creates two smaller angles. We have the smaller angle PQS and SQR. All right. So I know it's kind of messy, but what this says is that the pieces SQR plus PQS should add up to this entire angle PQR. So parts, again, add up to the whole. Just make sure you recognize what's the part and what's the whole. So let's take a look at this example 4. We're going to skip to that one. The measure of angle XWZ is 121 degrees, and the measure of angle XYW is 59 degrees. Let's find the measure of angle YWZ. And remember, when you see that little m, this means we're talking about numbers, right? So I want the actual degree, the numerical value. Let me go ahead and now label my problem. So I like to go ahead and sometimes mark up my diagrams. They help me see things. So I know that XWZ, that means that entire angle starting at X, right? Going down to W and turning and hitting Z, this whole thing is 121, right? So that whole thing is 121 degrees. Then I know that XWY, so if I want to trace that out, I'm starting at X, going down to W and up through Y. This little piece right here, that's going to be 59 degrees. So the question is, well, how do I find YWZ? Well, remember, parts add up to the whole. Right? So we want to think, what are the parts here? And I always encourage you guys to not look at the numbers right away. And let's just look at the angles, right? Look at the measurements of the angles using the points, because you're going to be needing to use those statements when we do proofs later on. It'll just help you out if you think about it. So what I mean by that is think about the parts. So we know that we have two pieces of this angle, and the entire angle. So I know it's kind of confusing when I'm saying this, but if you look at it, what's the big picture? What's the big angle here? And what are the two pieces that make it up? Right? So we're looking at this entire thing, xwz, and that's going to equal the sum of its parts, which are xwy I highlighted earlier, plus that other part, ywz, so the measure of angle. Let me erase that and get that out of the way. The measure of angle ywz. And then from there, all we're going to do is just plug in your values, right? So I know that that angle xwy was 59, right? I know that xwz was 121. And then I can just bring down everything else. I just substituted in 121 and 59. All right, go ahead and do your inverse operations to solve, and we should get the measure of angle. Oops. Let me do my inverse operation here. So we're going to go ahead and subtract 59 to both sides. Oops. Promise you I will get control of this pen with enough practice. So inverse operations here. The measure of angle ywz is equal to 62 degrees. Double check, is that all I was looking for? Right, look back at your directions. Yes, all we're looking for is finding the measure of angle ywz. So I've answered my question. So that's your angle addition postulate.